what we're going to work with are called nth roots. When we say nth roots, I'm talking about what's called, oh wait, we're talking about radicals. Oh, we're going to show you something. Nth roots. Here's what happens. We all know how to work with a regular old square root, right? Square root basically means take the square root of 16. What are two numbers that are exactly the same? You multiply together to get 16. 4. Now, why do we know that it's two numbers? Because that's what you're told, exactly. What happens here is that a square root is actually what we call an nth root. There's a little 2 out front here that you just don't see. It's implied that it's a 2, because you call it a square root, which tells you which basically is asking you what are two numbers, hence the 2, that are exactly the same, you multiply together to get 16. We would say that it was either plus or minus 4, right? Same deal when you work with, I don't know, the cube root of 27. What are three numbers that you multiply together that are exactly the same that get you 27? 3. Is it a plus or minus? No. Because, can you take the cube root of negative 27? What do you get? Negative 3. It works the same way. You can take nth roots of odd numbers if the nth root is, well, not I say odd, I meant negative. You can take the nth root of negative numbers if the nth root is odd. Okay. So what this is what we call an nth root. We just write it as that. It's an nth root. That number, that value of n changes. It just means how many times the number has to be multiplied together to give you something inside there. Yes, ma'am?
Wait, can you repeat if nth root is odd and
I'll show you here. If your nth root is odd, you can take an nth root of some negative number. It's okay. Whereas if we took like the square root of negative 16, we get imaginary. It's a non-real answer. I'm looking at, today we're going to talk about real answers. Okay, we're looking at finding real solutions to our problems. Okay, does that make sense?
yeah.
It comes up pretty quick when you start working with these things. I don't need to worry about this. We just did that. Let me go back to this real quick. Now, when I said the square root of x, I'm just leave it as this 2 real quick. This is called an nth root, or a square root is the exact same thing as an exponent. What happens is, this is the same thing as writing x to the 1/2 power. Okay? Same deal here. If it's the cube root of x, what do you think it's going to be? X to the 3rd. Which means my nth root rule would be what? The nth root of x is x to the 3rd. That's it. We interchange these quite often. Maybe not so much, oops, the x there. Maybe not as much today, but the old text starts off with a review of all your exponent rules. This one doesn't. It waits till like the 3rd section, which is kind of weird. Not used to that yet. But what's nice about showing you guys this little trick is that I can show you how we can simplify square roots with variables really quickly with this little trick. Okay? So let me show you this. What's the square root of 36?
6.
Or what's the square root of a quarter?
0.5.
It's a half. Plus or minus? Okay, they gave me a decimal, so I should give it a decimal. I hate decimals. What is the opposite of the cube root of 64? Yes,
Yeah.
no, maybe so? What's the cube root of negative 27? Are you surprised at which the e's that this is? So that means what?
It's more hard. It's supposed to get harder.
It's
Must get hard.
It's going to be boring. Yeah. Eventually it does, but it's not so much. It all follows the same pattern. There's not much difficulty to most of this. It's just some basic knowledge for today. There is one bit here. If I'm going to take the square root of, which one was it? It was, well, let's do this first. Let's say we have this. And I want to simplify that. What's that? There's a little bit of a trick to it. You're on the right track. We're getting to that with these absolute value stuff. This is where some of those absolute values come into play. Now, what happens a lot of times is that when I ask you guys to simplify these types of expressions, more often than not, I'm going to say, assume all variables are positive. And that alleviates the idea of this whole absolute value thing. But if you went through the Excel thing, you saw you had absolute values that came up, and the reason was because you had odd exponents and so on. Yes, sir? So what happens here is that, I'm going to show you two ways to do this. What's the nth root out in front that you don't see? That's 2. Are we okay with that? All right. So there's two ways to do this. Here's one way. The square root is what as an exponent? Half. So this is the same thing as saying the quantity x to the 4th, y to the 5th, z to the 6th, all to the half power. We okay with that? Now when you have power to power, what do you do to the exponents? Correct. What's half of 4? What's half of 5? What's half of 6? 3. So here's what happens. You get x squared, y to the 5 halves, and I'll show you how this is going to work here in a second, and z cubed, just by distributing the exponent. Now, there's another thing that happens here. I can simplify that fraction. 2 goes into 5 how many times?
Oh, twice.
And how many are left over? 1. So this is the same thing as breaking this one apart as x squared, excuse me, y squared, y to the half, and z cubed. Everybody okay with that? Yes, sir?
Would you want us, what would be like the y? Do you want us to put pi over 2 or would it?
I'm showing you why. I'm going to show you why this works in long form, and I'll show you the way that I'm going to want you to do it.
Okay.
Yeah, wait, why is it half?
What's that? Because there was half. There was 1 left over.
You just put it like that. Okay.
There's a reason why this is working here. 2 goes into 4 how many times? 2 goes into 5 how many times? 2 come out, 1 stays in. 2 goes into 6 how many times? That's what that is.
Oh, okay.
All you're doing is quick, simple division. You're leaving the remainder underneath your nth root. See how it's back to a fractional exponent, the 1/2? That means it goes back underneath the radical. That's why that works. Now, the reason that sometimes, how many of you guys actually went through some of that math Excel stuff and tried to do some of those? Did you see how some of them came through and gave you absolute values?
Yes.
Now, the reason why I was doing that is because when you simplify this out, whenever you square something, what's going to happen? What's it going to make it? It'll make it positive, right? Whenever you square something, it's positive, correct? If I raise something to an odd exponent, it has the possibility of being negative or positive depending upon the value. That's why they threw those absolute values around odd exponents, to make sure that it makes them positive. That's why it did that. Does that make sense? That's the only reason it did. To be honest with you, I think the Math Excel program is, I didn't realize that it was forcing that answer when I was picking through it, but that's the reason why it does. When we get to quizzes and tests, I'm not going to require that you guys worry about those absolute values because I'll put in there, assume all variables are positive. And by doing that, it alleviates you having to worry about that. That's kind of where it's getting at. So I know in the Math Excel stuff, if you weren't getting that because it was telling you about the absolute value, that's why. And that's why they had to group it on those odd exponents. Because if you cube -1, it's -1 times -1 times -1. 3 negatives make it another negative. By putting the absolute value around it, it gets rid of the possibility of it being negative. That's all it's doing. Okay? Does that make sense? That's why that worked. Share marks. So we can use that in these types of problems. If we assume that all of these are positive, what's the square root of 16x to the 8th? 4x to the 4th. Because all you're doing is you're taking the square root of 16, 4, and the square root of x to the 8th, what's wrong with LeBlanc?
Oh, I was trying to see.
Oh, I'm sorry.
No, the second
Oh.
one. Is that a one?
No, it's nothing. It just snapped in there when I did that. Okay. Welcome. Sorry, you had the look
I
of
think it's just like
I know,
carefully on one foot while hopping up and down. The square root of x to the 8th is x to the 4th. Because remember, the nth root that's out here is a 2. 2 goes into 8 how many times? 4. Any leftovers? Done.
But it's just like simplifying.
Yeah. That's all that is. It is very, very straightforward. Okay. 4 goes into 8 how many times? Any leftovers? 2 come out, how many stay in? None. 4 goes into 12, how many times? 3. And you'd be done. Now, Excel will tell you to put the absolute value around the y's because it's an odd exponent. That's the only thing. If you were getting that wrong, that's why it was getting it wrong. Okay. Cube root, a to the 6, b to the 9. Wanted to be out of here. 3 goes into 6, how many times? 3 goes into 9, how many times? And that's why I know, right? It builds up to something. It does get a little bit messier, but not by much. It really does. Because tomorrow we'll talk about multiplying and dividing. We're going to be simplifying the expressions as you go. Just like we played the game of war before with the different variables and exponents, it works the same way with nth roots. You convert things to fractional exponents and you add and subtract. That's it. It's really fast.
Take purposes change where you should like have it for like every $5 you raise and change to get 1 extra credit point.
Yeah. Yes, ma'am.
You said you were going to show us 2 forms of doing it?
Oh, yeah. That was the second way. By going through the long form like this, or doing it this way.
Oh.
Right, so both answers.
Yeah, sometimes I'll say leave it as an nth root. Sometimes it'll say leave it as an exponent. It just depends. And we don't leave it very often as beyond when we get to stuff like this, it'll look like x squared y to the 5 halves z cubed. It'll look like that when we have a problem like what does it look like? If I wanted to simplify something like this. Sorry about that. When we get to something like this eventually, then we can leave it in terms of fractional exponents. Because when you do this, you do a lot of distributing. You work with the nth roots and going through, and then you leave it as fractional exponents. We'll be able to do that by tomorrow. Yes, ma'am?
So like the long way that you did it,
Yeah.
if it's a cubed root, would you just do it by like
Because remember, that's the rule for the nth root, and that's why I wanted to take a minute and show you that the nth root of x is x to the 1 over n. By knowing this, you can go either way. I think it's just quicker by saying, hey, 2 goes into 4, 2 goes into 5, 2 come out, 1 stays in. That's it.
Yeah.
It's a really fast way of doing it. When we get to the monomial stuff, simplifying like this one, we'll keep it as a fractional exponent because it's really easy. Okay, you distribute and solve. Okay, not too bad so far. Squiggly, go away. It's too easy. Okay, if I take the square root of x to the 4th, will it always equal x squared?
No. Sometimes. Negative.
Ah, if let's say it's negative, well, if you use your order of operations, if I say that x is negative 2, if I substitute into here the square root of negative 2 to the 4th, will that equal negative 2 squared? Well, what's negative 2 to the 4th?
Negative 2 squared. No.
Well, what's negative 2 squared? 4, square that, what do you get? 16. What's the square root of 16? And then what's negative 2 squared? 4. Did it equal the same? Yeah, it works.
So always.
Well, show me one that doesn't. Now, think about it in terms of the way that you're using your order of operations. If you're using your order of operations, you should be okay. Now, when you go to your odd stuff, if I do the same thing here with the square root of negative 2 to the 6th, will that always equal negative 2 cubed? They're talking about just straight simplifying. Will this equal that? I know you're trying to solve for x. Okay? We're not worrying about the solve for x in this one. Okay? And it's tough to distinguish sometimes because there's still an equal sign. But here, if I do that negative 2 to the 6th, was it 64, I think? Because 2 to the 5th is 32. Times 2 would be 64. Use your calculator. I'm just going one easy person.
Why would you know for like x?
What?
Like the negative 2, like why would you put that in for x?
I'm just saying, I'm just using it as my example.
Okay, so like where we get negative 2.
I can use anything. I can use negative 1. I'm using a number that I know that will multiply out. I don't want to use like 1s and negative 1s. I'll use 2s because it's easy. Was 64? So what's the square root of 64? Now does that equal negative 8? No. But if this was a positive 2 and a positive 2, they would equal. So this would be your sometimes. That's where that works. So what you want to do, besides put your foot off the chair, you want to make sure you take a quick second and use numbers that are easy to work with. Try not to use negative 1, but use 2s and negative 2s to check it. And that's all you're doing. Use order of operations to work itself through. Okay? Is that okay? All right. Now, with any luck, you guys should be able to log to the Math Excel. Let me see if you guys can find this with our 15 clicks to freedom. Hannah, did you get in? It's still what? Oh, really? Oh, I thought I fixed that.
I think I got like a 1% because I was in the middle of answering a question.
Let's see. Go to click this.
That's so good. Our whole class is like helping each other.
Well, you guys are you're so nice to each other. Congratulations.
There's like one of us who understood like the absolute value of things. So it's like one person showing around.
See, I thought I changed the.
It says currently no upcoming assignments.
No.
Yeah.
Do you get to Math Excel from your website?
Yeah, just click on the algebra. Why does this let me do this? Have I not assigned it? It says you guys have an assignment.
Absolute value stuff. You like understood that?
It says that you may know how to work.
No, I
Oh, the date's wrong. Let me change that. All right.
Tell me that I would have unlimited tries and then I'd mess it up twice and then it kicked me off the problem and be like, you missed this one. I was like,
That's awesome.
yeah, I'm great.
All right, hold on. I could probably change that right now. What day is today? 28th?
Okay, go to the student page. Or piercing. You're trying to
I'm sorry. I thought I had changed that already.
Oh, so you can go to.
go back to try and get to the new.
Now check it. Refresh.
Refreshing.
So now it's at 72%. I cannot upload. I can't even get into that.
Did it work now? No, it should be 6.1. Refresh it. It should work now. Email text. Screenshot and email
Not
text.
even an option. Now it's not there.
Did you click Math Excel for all courses? Did you click Math Excel for all courses?
Yeah, now it's just not that.
This isn't showing up?
Sarah, did you find your?
No, I can't find it.
Not yet available. Not yet available. It's showing that it's there, but it's showing that it's not available.
All right, let me try again.
August 26th is the due date of the next assignment. I don't even know if I'm doing this right.
No, maybe it's free. I was like,
Alright, David, where do I go from here? Nothing.
yeah, so you won't be able to access the site.
Okay. I'm on, but there's nothing like there. Does it say there's any
This
assignments?
thing has 0%.
Oh, 0.
Tech. At D428. Why is this not showing up now?
Yeah.
People already told that.
No, that shouldn't have had anything to do with it.
It says 80% average.
All right, we'll just do this.
My hands just
Heck yeah.
I didn't drop.
What is that?
Try that now. Did it work? Refresh. Back out and log back in.
What's working?
It took you 5 minutes. You'll be fine.
I have 1 day and 9 hours to do it. Oh my gosh.
Good luck.
We all have the same question.
No. Yeah.
Yes, I can redo it.
Wait, do we have to do the parabola thing that's way
No.